and guidance systems of an approaching interceptor in order to increase the probability that the actual missile can travel through to its target. If the seeker or guidance systems of a kill vehicle technology on a ground-based interceptor, or GBI, cannot discern an actual nuclear-armed ICBM from a decoy, the dangerous missile is more likely to pass through and avoid being destroyed. MUCF is being developed to address this threat scenario. We will develop and test MUCF command and control strategies in both digital and hardware-in-the-loop venues that will prove we can manage the engagements of many kill vehicles on many targets from a single interceptor. We will also invest in the communication architectures and guidance technology that support this game-changing approach, a spokesman for the Missile Defense Agency told Scout Warrior in a previous written statement. The Missile Defense Agency has awarded MUCF development deals to Boeing, Lockheed and Raytheon as part of a risk reduction phase able to move the technology forward, officials said. Steve Nichols, Director of Advanced Air and Missile Defense Systems for Raytheon, told Scout Warrior last year that the MUCF is being developed to provide the MDA with a key capability for its ballistic missile defense system, to discriminate lethal objects from countermeasures and debris. The kill vehicle, launched from the ground-based interceptor, extends the ground-based discrimination capability with onboard sensors and processing to ensure the real threat is eliminated. MUCF could well be described as a new technological step in the ongoing maturation of what was originally conceived of in the Reagan era as Star Wars, the idea of using an interceptor missile to knock out or destroy an incoming enemy nuclear missile in space. This concept was originally greeted with skepticism and hesitation as something that was not technologically feasible. Not only has this technology come to fruition in many respects, but the capability continues to evolve with systems like MUCF. MUCF, to begin formal product development by 2022, is being engineered with a host of innovations to include new sensors, signal processors, communications technologies and robotic manufacturing automation for high-rate tactical weapons systems, Nichols explained. The trajectory of an enemy ICBM includes an initial boost phase where it launches from the surface up into space, a mid-course phase where it travels in space above the Earth's atmosphere, and a terminal phase wherein it re-enters the Earth's atmosphere and descends to its target. MUCF is engineered to destroy threats in the mid-course phase while the missile is traveling through space. An ability to destroy decoys as well as actual ICBMs is increasingly vital in today's fast-changing technological landscape because potential adversaries continue to develop more sophisticated missiles, countermeasures and decoy systems designed to make it much harder for interceptor missile to distinguish a decoy from an actual missile. As a result, a single intercept able to destroy multiple targets massively increases the likelihood that the incoming ICBM threat will actually be destroyed more quickly without needing to fire another ground-based interceptor. Raytheon describes its developmental approach as one that hinges upon what's called open architecture, a strategy designed to engineer systems with the ability to easily embrace and integrate new technologies as they emerge. This strategy will allow the MUCF platform to better adjust to fast-changing threats, Nichols said. The MDA development plan includes the current concept definition phase, followed by risk reduction and proof of concept phases leading to a full development program, notionally beginning in fiscal year 2022, Nichols explained. This highly advanced and highly technical kill vehicle takes a true dedication of time and expertise to properly mature. It is essential to leverage advancements from other members of the Raytheon kill vehicle family, including the redesigned kill vehicle, Nichols said. While the initial development of MUCF is aimed at configuring the kill vehicle for a GBI, there is early thinking about integrating the technology onto a standard Missile 3, or SM-3, an interceptor missile also able to knock incoming ICBMs out of space. The SM-3 is also an exo-atmospheric kill vehicle, meaning it can destroy short and intermediate-range incoming targets. Its kill vehicle has no explosives but rather uses kinetic energy to collide with and obliterate its target. The resulting impact is the equivalent to a 10-ton truck traveling at 600 miles per hour, Raytheon statements said. Ultimately, these multi-object kill vehicles will revolutionize our missile defense architecture, substantially reducing the interceptor inventory required to defeat an evolving and more capable threat to the homeland, a Missile Defense Agency spokesman said. A U.S. military upgraded exo-atmospheric kill vehicle, or EKV, a kinetic force weapon that slams into its targets, destroyed an intercontinental ballistic missile for the first time during a Missile Defense Agency test of the ground-based mid-course defense system several months ago, The Missile Defense Agency's first ever successful intercept of an ICBM target using a ground-based mid-course defense system, using the kinetic force of an exo-atmospheric kill vehicle, EKV, to destroy the target, is paving the way toward advanced future kill vehicles able to discern and attack multiple approaching threats, industry and Pentagon officials said. During the test, an ICBM-class target was launched from the Reagan test site on Kwajalein Atoll in the Republic of the Marshall Islands, a missile defense agency.